So let us start Unit 5 Satellite Applications, the second part. Okay, the topic that we are going to see is the Digital Broadcast Satellite Service, or we call it as the DBS service. So this uh, Direct Broadcast Satellite Service, which is basically a digital type, is an artificial satellite which usually sends a satellite television signals only for home receptions. We have an television station or the TV station, like in TV studios, Gemini TV, ETV, Sun TV, or whatever might be. Those will be present in the earth. So that broadcasting station will only transmit signals. So that signals will be transmitted to the satellite which is present in space. So then that satellite will receive the signals from the TV studios, TV stations, and then transmit it towards the receivers in Earth station to specific receiver deployed at homes. So all in all, we can say that this is a method of receiving satellite television by means of a signals transmitted from direct broadcast satellites. Specific satellites of broadcasting will be deployed in space. So the overview of working of this is that you can see we have a programming source, which is the TV studios. Those TV studios will send signals to the broadcasting satellite. So in turn, the broadcasting satellite will send the signals directly to the dish antenna. That dish antenna will capture all the signals and it will be directly connected to the television set-top box. Let's see a set-top box. Just at the receiver, we have a television set which is receiving the signals whichever is being transmitted from the source. So this direct broadcasting service will have 5 different components. One is the programming source. Next one is the broadcast center. So this is a broadcast center. Then we have the satellite in space. Then we have the satellite dish and the receiver. So these are the 5 components of direct broadcasting service. So the working of this direct broadcasting service is that it operates in C band and Ku band. Okay. At present, there are 4 commercially available satellite television technologies which can be divided into this 4 bands. One is C band, then Ku band plus Ka band, which we call it as direct TV. Then we have the Ku band alone, which is used, which is called as dish band. Another TV which is used is a Globecast World TV in Ku band. So these are the specifications of different band designations. VHF band ranges from 0.1 to 0.3 gigahertz. UHF, ultra high frequency, the frequency range is 0.3 to 1 gigahertz. The L band is from 1 to 2 gigahertz. S band is 2 to 4 gigahertz. C band is 4 to 8 gigahertz. X band is 8 to 12 gigahertz. Ku band, which we are using here, is 12 to 18 gigahertz. K band 80 to 27 gigahertz. Ka band 27.0 to 40.0 gigahertz. V band 40 to 75 gigahertz. W band 75 to 110 gigahertz. Millimeter waves 110 to 300 gigahertz, and micrometer waves 300 to 3000 gigahertz. this is the working of an digital direct broadcaster satellite television receiver. You can see the television set which is present at homes will be divided into two parts. One is having an antenna part, the dish antenna. Second one having the set-top box or the receiver part at inside the home. So we have the indoor unit as a set-top box and the outdoor unit as your dish antenna. So this dish antenna which is being deployed receives your direct broadcasting television signal in the frequency of 12.2 to 12.7 gigahertz operating in the KU band. So these signals are given to an low noise amplifier structure LNA and this low noise amplifier will send this obtained 12.2 to 12.7 gigahertz of frequency into an image rejection band pass filter where the image interferenced signals will be removed out. Then it is given to a mixer. You can see a mixer that oscillates at a local offset frequency of 11.3 gigahertz. Then it is given to an intermediate frequency amplifier operating at 900 to 1400 megahertz. So this 12.2 to 12.7 gigahertz would be down converted into an intermediate frequency of 900 to 1400 megahertz of frequency signal. Then this low noise block converter gives the signal to another intermediate frequency amplifier stage where this 900 to 1400 megahertz of intermediate frequency signals are being further down converted to 70 megahertz of frequency. So what are the same procedure of using a local oscillator which is tuned by a local oscillator, mixed band pass filter, and then it is down converted to 70 megahertz of intermediate frequency by this amplifier. So then we have the detector being used, which is the QPSK modulation is being used at your transmitter. So we use an QPSK demodulator at receiver. So that is given to the baseband amplifier. So then this baseband amplifier is connected and it is given to the baseband amplifier is given to this decoder. Then following that is your deinterleaver, then a decoder, then a digital demultiplexer. Here we are using MPEG 2, Moving Pictures Experts Group 2 decoding the receiver, then a digital to analog converter where the signals are converted from digital to analog. Then the corresponding video unit and audio unit, whichever it is being set up, is being connected to that. So the movement of pictures or images can be visualized in video. The voice or the speech signals can be resembled through audios, which is connected to the analog output of TV set. Then the block diagram of coding and decoding operation in a direct broadcast satellite television signal. So the data input which is given here is given to an encoder. Okay, we had seen that in this diagram. It is given to an inner decoder and outer decoder. So what it is we are going to see here. So the data is given to an RS encoder, Reed Solomon encoder of n comma k 204 comma 188. Then it is interleaved and it is given to a RAID 3 bar 4 convolutional encoder. Then that is given to a de-interleaver and then to a Reed Solomon code, which is given as to your data output. So there are two segments possible for interleaving and de-interleaving. 13 to 17 is used for error correction, and however for digital data transmission 23 to 27 bits is being used for data transmission. So interleaving is frequently used in digital communication and storage systems to improve the performance of forward error correction is being done in DBS. So interleaving is widely used for burst error correction, as you all are familiar with burst errors that you would have studied in information theory and coding or in digital systems. So the transmission without interleaving will look like this. You can see that transmission without interleaving, which is a error-free message, will look like this. And if there is a burst, if there is a error in the burst, you can see that this will be transmitted. So with this you can find what is an interleaving is used for. Same error-free code words, interleaved information, transmission with a burst error, and the codes received after de-interleaving will look like this. Error-free codes this, interleaved codes this, transmission with a burst error occurring at this part, so will lead to this type of received codes. So in each of the code words, this AA, EE, FF, GG, only one bit is altered. So 1 bit error correcting code will decode everything correctly. Okay. So there is a disadvantage of using this interleaving in DBS is that it takes too much of time. Takes too much of time to retrieve the data information. So that delay causes more amount of packet transmission to be decoded again and again. That's what they had moved on to a next standard called MPEG, Moving Pictures Experts Group. So this Moving Pictures Experts Group is a working group of authorities that was formed by ISO and IEC to set standards for audio and video compression and transmission. So MPEG has the following compression standards and formats: MPEG 1, MPEG 2, MPEG 3, MPEG 4. So VCD uses MPEG 1, DVDs and DVBs uses MPEG 2, DVB S2, standard S2. Standard 2 version uses MPEG 2 as well as MPEG 4. So depending upon application, so this MPEG standard is being deployed. So MPEG 2 is the widely used format of digital television signals that are broadcast by terrestrial, cable and air broadcast television systems. It also specifies the format of movies and other programs that are distributed in DVD and similar discs. MPEG 2 removes both the temporal redundancy and spatial redundancy that are present in motion video. The temporal redundancy arises when successive frames of video display images of the same scene. If it is common for the content of the scene to remain, it is to be remained as fixed or to change slightly between the successive frames. So the spatially redundancy occurs because of the parts of the pictures called pixels that are often should be pixels. Pixels that are often replicated with minor changes within a single frame of video. So this you can see the temporal redundancy and spatial redundancy of three different standards that are being widely used. MPEG 1, MPEG 2, MPEG 4. For video conferencing, we use a data rate less than 0.384 megabits per second. So MPEG 4 is recommended. For less than 1.5 megabits per second video in a window, MPEG 1 is recommended. From data rate of 1 to 2 megabits per second Mbps, video home screen, quality full screen is recommended. If the broadcasting is of 2 to 3 Mbps, MPEG 2 is recommended for broadcast NTSC. For broadcast PAL, 4 to 6 Mbps. For professional PAL broadcast HDTV, MPEG 2 standards are being deployed. So you can have a view on this, the different data rates, the different television standards, and what type of compression channel is being used for it. Any queries you can type in chat box. Next is the basic operation of an encoder. We have the analog video sampling signal, Then it is given to an interframe redundancy, which quantizes the samples. It runs through the run length compressor, then to a buffer store. Then these signals are being given to your DBS system. So this is the encoder and decoder of MPEG. We have the input video, we have the motion estimator, then it is given to the motion compensator, then to the length coder. We'll be using Huffman encoding most probably in both the encoder and decoder, as well as since the Shannon-Fadon codes are much lesser efficient than the Huffman codes, so the preference of Huffman coding is being done. So these are being motion compensated by using an embedded decoder, which takes IDCT, inverse discrete cosine transform, for better processing of images. So the same is replicated at your decoder in reverse. So we have the Huffman decoder, we have the inverse quantization, then we have the discrete cosine transform, then it is given to the frames that are being stored, then to the reference picture, then to the motion compensator. Then we get the output signals at receiver. The same information. So the advantages is that this allows storage and transmission of movies, that is using currently available storage media and transmission bandwidth. Better coding quality at higher data rates in comparison with MPEG-1. It is often used to create movies to be distributed over the internet. This gives resolutions of 720 cross 480 and 1280 cross 720 at 60 full picture cell frames per second, 60 frames per second, full CD quality audio, significant required for computer encoding. So the main disadvantage of that is that the arithmetic procedure is very long. Video compression is that much not efficiently achieved for HDTVs. So the MPEG-4 standard. The trends of users of MPEG-4 standard right from 2003 to 2015. There is a gradual increase till 2010. There is a drastic increase from 2011 to 2015. Number of subscribers of this DBS service in millions. This DBS seems mostly being applicable to persons who are either descendants with cable television or who live in the areas where this cable television cannot be served. So the DBS television systems operate with small antennas and low-cost receiving systems that offer a very large number of videos and audio channels, making them attractive to customers. The delivery of bitstream through direct broadcast satellite can be adapted to serve internet users who require the download of large blocks of data. So any queries in the direct broadcast satellite, you can type in chat box. I'll give you 5 minutes of time. Then we'll proceed on to the DTH service. Since there are no queries, I'll proceed on to the next topic called DTH service, which is direct to home service. So this service is a digital satellite service that provides television services direct to the subscribers at home. This DTH does always with the need help of a local cable operator. It directly broadcasts the signals to the consumers or the TV receivers where it's been installed. The installation of a DTH television consists of a dish antenna, probably in diameter size of 60 to 90 centimeter, a conventional TV set, a set-top box, a coaxial cable between dish and the set-top box. So these four are required essentially. The installation of a DTH television consists of a dish antenna, probably the diameter of 60 to 90 centimeter, a conventional television set, a set-top box, a coaxial cable between dish antenna and a set-top box connecting them. The specification of DTH is that the frequencies for DTH vary from region to region, but it always lies in the Ku band of microwave. So the uplink frequency range is 17.3 to 17.8 gigahertz, downlink frequency range is 12.2 to 12.7 gigahertz. An electronically controlled polarizer is used at receiving terminal for converting circularly received polarized signal to a linearly polarized signal, where a DTH television satellite carries up to 32 high power transponders. The digital TV signals are transmitted as 20 megabits per second, having QPSK signal modulation, which occupies about 27 megahertz of transponder bandwidth frequency for a single channel. So the MPEG-2 format is used for video compression. So this is an setup of the features of DTH. You can see a hut is there, a DTH is being installed in the tree. You can see at the left side. So some of the features are that it offers better quality picture than cable television. It can reach remote areas where terrestrial transmission cable televisions have failed to reach. This DTH also allows for interactive television services such as movie on demand and email services too. In DTH, the payments will be made directly by the subscriber to the satellite company who offers this service. The network of DTH is this: broadcasting center, which is present at station, transmits the signals to the satellite, and from the satellite, having a transponder in the Ku band frequency, sends the signals to the direct to home dish antenna with the low noise block converter. Then it is given to the television set or to the viewing set through the set-top box. So the components are programming source, broadcasting center, receiving terminal, 3, which are interconnected. So the programming source are simply the channels. Those provide programs for the broadcasting. The satellite TV provider gets programming from two major sources. One is from the international channels, for example, like HBO, ESPN, CNN, and from various local channels like Sahara TV, Doordarshan, and etc. So these channels usually have a distribution center that beams their programming to a geostationary satellite. So you can see the examples of both the international channels. Star World, Star Plus, ESPN, NGC, NDTV are all examples of your international channels. Whereas Aaj Tak, Sony Max, Sahara, Manoranjan, it's Disney, not Disney, Jay TV, Sun TV, Gemini, and all comes as your various local channels in India. So they program it. So the broadcasting source is being done by using an MPEG-2 standard, where this is the picture of an broadcasting satellite, sorry, broadcasting earth station which sends signals to the satellite. Okay. Then the receiving terminal at the receivers at homes will have a dish antenna. So from that it receives the signals. It is fed to the interfacing cable. So that cable connects your set-top box in the dish antenna. Then with the help of your TV remotes or the set-top box, you can visualize it on the screen of television sets. You can see that example here. So this dish antenna, which is used for DTH, is always a parabolic surface, which we call as a bowl-shaped surface, and it has a central feed horn antenna. You can see at the center we have the feed on. The satellite dish is just a special kind of antenna designed to focus on a specific broadcast source. To transmit a signal, a controller sends it to the horn, and the dish focuses the signal into a relatively narrow beam. So the dish on the receiving end can't transmit information. It can only receive it. Okay, keep in mind the dish antenna having the horn will only receive it. It cannot transmit the signals again. So the receiving dish works in the exact opposite way of the transmitter. When a beam hits the curved dish, the parabolic shape reflects the radio signal inwards onto a particular point, just like a concave mirror focusing light onto a particular point. So the curved dishes focuses the incoming radio wave signals to the feed antenna. Then we have the LNB block, low noise block converter. So this low noise block converter is used to convert the 12.2 to 12.7 gigahertz of bandwidth to 950 to 1450 megahertz down conversion. So this LNB sits on an end of a arm and faces the parabolic reflector dish, which focuses the signals from a satellite, and it is fed to the horn of the LNB. So these are different types of LNBs. Then we have the set-top box at your receiver. So the basic set-top box takes the signal from the satellite dish and converts it into a signal that can be used by a TV, sound amplifier, etc. So the set-top box can act as a gateway between a television or a PC and a telephone, satellite, terrestrial, or a cable feed. So this set-top box also accepts commands from the users and transmits these commands back to the network operator only in the exceptional cases. So these are the types of set-top boxes depending upon the service. The broadcast set-top box, which uses analog broadcast, satellite cable TV, DTH, which uses the NTSC or PAL television systems, connected televisions, IP televisions we call it as, which is an example of integrated television set. Then we have the multimedia computers, then game consoles, we can play networking games like PlayStations, connecting media devices, then multimedia mobile telephone systems. All these are examples of different types of set-top boxes. So major DTH service providers in India are the Tata Sky, which you all are familiar, Airtel, Mediacom DTH, Direct to Home, Sun Direct, Big TV, and Dish TV. All these are vendors of DTH service providers in India. You can contact any one of them to install and DTH service at your home if required. So the benefits of the DTH. For example, I taken a Dish TV. So choosing the values from You can choose packs, you can choose channels, you can have combo packs, you can use set-top boxes. It's your wish. Okay. So the main benefits is that it's cost-effective communication, small size terminal, can provide up to 4,000 channels and 2,000 radio channels through a click of button, and thus bringing the world's information, news, entertainment to your home in just a click. The DTH services bypasses mediators, and thus content provider comes with a customer directly. That the customers can contact the DTH service provider and they can access the channels, eliminating the use of an intermediate mediator in between, like the cable operators. DTH services are transparent, providing digital quality video, audio, radio, and internet protocol to all at equal prices and other benefits with reliability. The limitations is that during unfavorable climatic conditions, the service remains unavailable. The service is interrupted in the case of the direction of the dish is disturbed. Transmission gets interrupted during the sun outage. So these are the three limitations of a DTH service being used in all, not only in Tata Sky, in all. So this is how the positioning of a DTH service is there. A geostationary plays an important role for DTH service. They are positioned at an exact height of 36,000 kilometers above the Earth. They can solve the problem of range and distortion by transmitting broadcast signals, where polarization is being used. So it is used to give a wave to give specific direction to a transmitted signal. The signal transmitted by satellite can be polarized linearly or circularly. Horizontal, vertical, left hand or right hand. So the DTH connects urban, rural, and remote areas of the country and provide desired information, communication, education, and entertainment at a click of a button. So any queries in this DTH, you can type in chat box. DTH is a subdivision of DBS. Direct to home service is a part of your direct broadcasting satellite system. They are not equivalent. Direct broadcasting satellite is different from direct to home service. So using the direct broadcasting satellites, we will be using DTH service. We are utilizing it. Okay, got it, Vishnu? Okay, thank you. Any other queries you can type in chat box. Okay, since there are no further queries, I move on to the next topic, which we call as DAB, digital audio broadcasting. So this digital audio broadcasting came into existence by replacing the amplitude modulation and the frequency modulation audio broadcasting services, which used FMs. SW1, shortwave 1, shortwave 2, SW2, and MW, which was used in Akashvani or in All India Radio. So very well, this digital audio service broadcasting came into as a mobile reception, which had a future of high robust against the multipath receptions, which had a high quality digital audio services equivalent to the quality of a CD, compact discs. Then the ancillary data transmission, that is the traveling and the information, still satisfying the moving pictures experts group. Then the larger coverage area than the current FM and AM systems, and using the frequency spectrum very efficiently with the low transmitting power was the futures of the DAB. So the specifications is that it is used in-band on-channel IBOC, which was given by NRSC standard. It was used by the Japanese standard for digital television and audio, termed as ISDB. So the history of DAB came into existence in the 1980s, where the first digital sound broadcasting systems provided CD-like audio quality for satellite deliveries. It was using frequency bands of 10 to 12 gigahertz with a little sound data compression. At that time, it did not aim for mobile reception at all. It was aiming only for a device. In 1997, the Eureka 147 project was born, where the first digital audio broadcasting standard was achieved in 1993. So in 1995, the ETSI adopted the digital audio broadcasting as the only European standard for digital radios. This did not have video broadcasting, only audio broadcasting. So the specifications are that 1.5 megahertz bandwidth, frequency of 30 to 3 gigahertz is enough. 30 megahertz to 3 gigahertz is enough. 1.5 megabits per seconds was your signal rate, and 8 to 384 kilobits per second was the audio rate. So up to there were 33 mono audio channels or 12 stereo audio channels being used in DAB. So this is the block diagram of a DAB transmission. DAB signal transmission. You can see the data service being provided. General data service is obtained collectively from your FIC data services, multiplex control data, service information, program associated data, which is the audio, program services. We use the MPEG layer, which is operating at 24 kilohertz to 48 kilohertz PCM audio signal. So that is being divided into frames, DAB frames, and it is sent to an access scrambler, optional conditional access scrambler, then energy dispersal scrambler, then to the conversion encoder, then to the time interleaver, then to the main service multiplexer. So these are given to the transmission frame multiplexer, then to the OFDM signal generator that generates all these signals in sequence with the synchronization generator to your transmitted output. So let us see each and every block separately. The important block, which is your PCM audio signal, MPEG-2 encoder. So which obtains the signals from the PCM speech signal in the range of 24 kilohertz to 48 kilohertz with an energy dispersal scrambler, conversion encoder, time interleaving, QPSK symbol mapping, and OFDM signal generation. Then it is given to your RF unit. So this is the digital audio broadcasting world coverage map, how it is being present, how it is being utilized. So the red indicates the operational services of the DAB. The pink indicates the pre-operational services. The blue, you can see this blue, dark blue, experimental services of the DAB. And violet is the advanced interest of this service, which is being done by China, India. In this map, you can see coverage. Then this sky blue indicates growing interest in these regions. These regions are in of interest, showing interest. So these parts are showing interest of this DABs, whereas this very light blue shows the information about the countries that they are not interested in DAB. So DAB world coverage. So IBOC is your in-band one channel. It is a high definition radio project which permitted a smooth evolution from current analog radio broadcasting to fully digital radio broadcasting. This allowed broadcaster to keep current analog transmissions, and which did not require for a new spectrum for AM or FM transmissions. This had equal CD quality as for frequency modulation, FM stereo quality sound for AM trans stations. There was no need for new towers or transmitter sites. New data capabilities for AM and FM stations was being deployed. So history was that it was started in 2001, approved by the FCC in 2002. In 2003, first AM and FM stations began with HD radio. Then in 2005, the DAB standard with IBOC NRSC 5 was approved. The IBOC DAB, which had used RF transmission subsystem, coding and interleaving mapping, OFDM modulation, up conversion to AM or FM. Then in transport and service multiplex, it took the audio and the data information generating stream of packets. In audio and data input systems, it had audio source coding. So this is the block diagram for that. Block diagram of the DAB, where the main program service MPS audio is given to the audio source coding and compression. Then with a delay it is given to the modulation segment, and a part of the signal is given to the audio transport, which is manipulated along with the PSD transport. Then a supplement program service audio is given to an audio subsystem. This audio is given to your audio transport. Then SPS data is given to your PSD transport. Then satellite information service is given to SIS data transport. Advanced data service data is given to ADS transport. So all these things are given to a service multiplex, then to a channel encoding, and to an appropriate modulation, then to the nearby station. Then it is given to your satellite, from the satellite to an IBOC receiver, and in reverse of this block. Demodulation, channel decoding, service demultiplexer, and the corresponding MPS, which is being obtained. Here the transmission subsystem, the interface layer having the function of transferring PDU frames. The logical channels gives the specific grade of service. The channel coding is done for scrambling, which uses QPSK 16 QAM, 64 QAM, or 2048 OFDM modulation schemes. Next is the radio propagation effects.
பையன் மெசேஜ் அனுப்பிச்சிருந்தான் அடுத்த நான் எக்ஸாம் தரேன் எனக்கு போகணும்
Next is the radio propagation effects, which plays a major role in all the direct to broadcasting satellite services. So the signals that are being sent from satellite to the Earth surface, if there is an mobile, which is the user, if he's traveling in a car, the signal will be received in this many parts. So it could be reflected from a building, we call it a reflected signal. It could be elevated from a obstruction, which we call as a diffracted signal, and it reaches the mobiles. So if there are urban regions, so this has to be considered while designing DAB or as well as a DBB. So the source of attenuation is that any objects which obstruct the line of sight is a source of attenuation. The diffraction of the boundaries of obstructions, which create low frequencies. In high frequency signals that require line of sight, radical signals too. The multipath effects also leads to drastic effect in performance of the DAB and DBB.
It is audible. It is audible.
Playing games.
ಎಲ್ಲಿರುತ್ತಾ?
The reflected parts, the direct parts, the diffracted parts all reaches the receiver. So this has to be eliminated. So a type of technique that is used for eliminating all these things is your CDMA. CDMA is a code division multiplexer, as you all are familiar, which uses pseudo random noise codes where all the channels use the same frequency band and transmit simultaneously. And the signals are recovered by using correlating received signal with PN codes being deployed. So the CDMA with DAB is an application where signal hiding and non-interference with existing systems occurs, accurate ranging, multiple user access, and multiple tolerance. So this is your CDMA generation where data is sent to an modulator. We use probably a modulator addition. Then a pseudo noise generator is being given. Since it is used for binary phase shift, so BPSK modulation, then a local oscillator, then to its RF output. So the equivalent diagram representation is given at the bottom. Data signal, PN code of 10 chip length, and then the output spread signal will look like this. So CDMA data is to be transmitted and it is spread by modulating the data using a pseudo random codes. Then the received signal is recovered by multiplying the signal by the original spreading code. So any queries till this, you can type in chat box.
Nalar